Ms. Thompson. We are talking today about 2.3 polynomial division. I'm going to do long division in the first video and then synthetic division in the second, so you can see both. So we have 2.3a and 2.3b. Division in general is just essentially trying to do the same thing we do with numbers when we divide. So if I divided, for example, 10 divided by 5, we know the answer is 2. And the answer is 2 because 2 times 5 equals 10, right? So when we're dividing 10 by 5, we're saying what number times 5 gives us this 10 back. And the same thing is essentially true for long division. So when we have polynomials, if f of x and d of x are polynomials, then you can write f of x, we can take f of x and say something, which is q of x, times that d of x gets us our function. So a division, essentially, f of x divided by d of x is going to be what number times d of x gets us f of x, and we might have a little bit of a remainder, just like we do with numbers sometimes. So that theory is less important than actually what it looks like in practice. And so we're going to do a couple examples here. The first thing I want to think about is just how we set this up. So our question is example, divide f of x equals 3x cubed plus 4x minus 2 by x squared plus 2x plus 1. This is a long problem, and the first thing we want to do is set up a division bar like we would in 5th grade or 6th grade when we were learning long division. Now on the outside of the division bar over here goes what we are dividing by. So this number right here, x squared plus 2x plus 1, goes on the outside. The big function that we're dividing goes underneath. But notice that in that function, I've got 3x cubed, and then I go straight to 4x. I don't have an x squared term. Where is that x squared? And even though it's not here, even though I don't have anything times x squared, I need to make sure when I add this f of x under my division symbol, under my division bar, I have to make sure I have a placeholder for it. So when I read my function down, I should have x cubed, x squared, 1x, and 0 x's. And so whenever I'm doing anything with my functions, I need to make sure in this division that I've got each power of x represented. X squared, x to the first, x0, x cubed, x squared, x to the first, x to the 0. So that's what this note over here means. Must fill in any missing powers of x. So let's think about how we do our division. The first thing we always do is we pay attention to this number out here. We really mostly care about this x squared. And so what we do is we think, what number times x squared gets me 3x cubed? Right? What number times x squared gets me 3x cubed? Well, something times x squared, I'm going to need that 3. So 3 times x squared is 3x squared. But I want x cubed, and so I need 1 additional x. So I'm essentially trying to do that backwards multiplication. So division is just what times this number gets me this answer. And what I want to do now is I want to essentially distribute that 3x to all of my other numbers and see what's left over from my big polynomial here. So I'm going to do 3x times x squared, 3x times 2x, and 3x times 1. And I'm going to line them up nicely underneath my polynomial. 3x times x squared, we know is 3x cubed. That's why we picked 3x squared. 3x times 2x is plus 6x squared. Now you can see why that placeholder is important, because now I've got these like terms above each other. And then 3x times 1 is plus 3x. All right, so what I've done is essentially I already know that 3x times this number gets me here. And the question is, what's left over? What do I still need? And so what I actually do is I subtract this from our original polynomial, and I see what's left over. 3x cubed minus 3x cubed is 0, so I'll leave that blank. 0x squared minus 6x squared is negative 6x squared. 4x minus 3x is plus x, or plus 1x, and that's it. But notice I've got these three terms, and so I actually have to bring down this 2 now, just like I did in long division in 5th grade. Now that I'm ready for it, and I'll add my minus 2 here. Now what essentially happens is this process starts over. We're done with our 3x, we figured that out. And now what I want to do is figure out how many times does x squared go into 6x squared, right? I was looking at 3x cubed, but now I've taken care of that. And what I have left over is this 6x squared. So I know I'm going to need a negative 6, and x squared actually means I don't need any more x's. So it's just a negative 6. Then, just like before, I want to distribute that term to all three of these places. So negative 6 times x squared, negative 6 times positive 2x, which gets me a minus 12x, and negative 6 times positive 1, which gets me negative 6. All right, and just like before, now what I essentially say is that 3x minus 6 times x squared plus 2x minus 1, or plus 1, I first got this from distributing the 3x. Now I've got this from distributing that negative 6. And again, my question is, how much is left over? What happens when I subtract? These terms are going to cancel out, but x minus negative 12x gets me 13x, and negative 2 minus negative 6 gets me a positive 4. All right, now I would bring down the next number, but there is no next number over here. We are gone through our whole equation. And so I'm actually done doing the actual division process, and I just need to figure out what is this leftover thing about and how do I write my final answer. So at this point, I actually can't go any further. This is kind of my stopping point. So I'll have this here. Stop. All right. So what we get down here, this piece is actually called the remainder. This is the stuff that didn't divide cleanly, that didn't come out with a nice thing. And at the top up here, this is our kind of the first part of our answer. So if you think about something like, just as an example, like 13 divided by 4, you might think, oh, well, 4 times 3 is 12, and then I've got this remainder of 1 left over to get me to 13. But we also sometimes write this as 3 and 1/4 left over, and this is the format we're going to look at today. And so what we get is actually our answer is 3x minus 6, and our remainder we put as a fraction, 13x plus 4, over our what we divided by, x squared plus 2x plus 1. And this is actually our final equation. All right, this takes a little bit of practice, so no worries, we will get better with it. And the next video talks about synthetic division. All right, good luck.